My name is Douglas Bean. Welcome to the third video exploring graph databases with Neo4j. In this video I'm going to demonstrate modeling a many-to-many relationship in a graph database with Neo4j, and I'm going to compare it to how a one-to-many ad hoc relationship might be implemented in an aggregate data store, that is a document database. I'll begin by showing the ad hoc one-to-many or parent-child relationship implementation in a document database. This diagram shows two documents, one a team document and the other a team members document. To establish a relationship between them, we add a foreign key property to the team members document that references the ID of the team document. Then we add an index to that foreign key property. When we want to get one of the team and team member relationships from the database, we execute two queries in our application code and we combine the results. I've used this pattern in two different projects for two different clients. I believe it is a common practice with document databases. This is about as far as we can go with relationships in a document database. I did an experiment modeling a many-to-many relationship in DynamoDB, which is the document database of Amazon Web Services. I added a join document between two other documents, just as a join table is used in SQL databases to establish many-to-many relationships between tables. The exercise quickly showed itself to be an absurd and unmanageable solution to the problem of storing many-to-many relationships of connected data. Document databases are great technologies for storing independent aggregates of data. They just are not designed for storing relationships. Now let us turn our attention to modeling a many-to-many relationship in a graph database. The domain I chose is a school with students, courses, and teachers. Now, this cipher code, well, first let me make sure I clear out the current graph in the community edition. We'll add some courses, students, and teachers. Now we'll add some indexes on each of our data nodes or data node types. We have to do one at a time. Now remember from the previous video that indexes are used to find the starting points, to find the data nodes that are the starting points of our queries, or the starting points of our graph traversals. Now let's create some relationships, some sign-up relationships between courses and one of our students to assign those courses to the student. Now we'll do the same for our other student, Jill. Now we need some teachers for our courses. We'll have Aristotle teach philosophy by creating a relationship between the philosophy node and the Aristotle teacher node. And we'll have Emily Dickinson teach our English classes. Now let's assign some grades to one of our students. We'll do that by creating grade nodes and relationships between our student and our courses. Now we'll do the same for our other student. In the labeled property graph, nouns usually become data nodes and verbs usually become relationships. Now let's execute some queries. And this is what classes is Jill signed up for. We get our 3 classes. Who is signed up for Chaucer? Jill and Bob are signed up for Chaucer. Who's getting an A in philosophy? Bob is getting an A in philosophy. Who's teaching Introduction to Philosophy? Aristotle. Now let's get our whole graph and see what we have. Now let's assign or add a label to one of our students. In Neo4j, in the labeled property graph, data nodes can have more than one label representing different roles in the domain. And in this case, we'll assume that Jill is a graduate student, so she'll be a teaching assistant. So we'll assign that label to her. Now we'll create a relationship called assist to the course that she will be teaching. And we see that Jane has 2 relationships to philosophy. She signed up for it and she also teaches it. And we can query our graph for all the teacher's assistants, which at this time is just Jill. Let's get the whole graph again. Now, I want to show you some other things in this Neo4j browser. This browser is a great teaching tool, a great learning tool. It will help us, or it helps me to remember the syntax for certain queries. We can query by certain data nodes, grades, students. Of course, we can query by relationships, and we see the syntax that's added to our browser. Let me show you a couple of other things. We have some basic queries. We can create unique constraints on data properties. We have example graphs. Let me play the movie graph. This script, we can execute this script and it'll create a movie graph for us that we can then query. There's also this example of north wind graph. It's actually pretty cool. What it will do, it'll bring us step by step through the process of migrating a SQL database to Neo4j, and it'll create the corresponding nodes and relationships in our graph, in a graph database. Now I'm at the end of this video, but there's a couple things I want to mention. One is that I examined 2 other graph databases, and all of this data modeling and querying that I did here, I was not able to do in those other 2 graph databases. It was just cumbersome, and it just didn't work very well. And it seems like the exercise was a whole waste of time, those other 2 graph databases. But if anything, it showed me what a mature piece of technology Neo4j really is. And another thing is that many domains are real-world graphs. That is, that they are irregular data structures that resist being fit into a rigid schema, and they are well suited to be modeled and stored as a graph. Thank you for watching my exploration of graph databases.